Hello and welcome to a brand spanking New Year's. I hope you had a great Christmas holiday and you're well rested and you are ready to go. So in this video, we are going to review for our upcoming test, which you will have on the 3rd of January. So please forgive me for this wrong date. This test date is not valid anymore, but your new test date is on the 3rd of January, the day you come back to school. So in this test, you will have 8 questions, 2 each from the following topics. You will have 2 questions over finding molecular formula. You will also have to find percent composition, then writing and balancing equations, and then writing a statement from an unbalanced equation. So in this video, I'm going to go over one example of each, and hopefully the notes you take from this video will help you on the test. So let's get started. So your first question is about finding molecular formula. You have 4 elements in this problem. You have carbon, hydrogen, nitrogen, and oxygen with the following percentages. So with the molar mass given and the percentages given, the 4 of these, your first task is to rewrite these percentages as grams. So what I will do is I'll do the process for carbon, and then you can follow suit for the other 3 elements. So for carbon, it would be 49.48 grams. And then what you have to do is convert these to moles. So what you will do is you will take your grams and you will divide it by the molar mass of carbon, which is 12.011, and that gives you 4.12. You will do the same for the rest of the elements, and go ahead and pause the video. On the next screen, you will simply look at my moles for all 4 elements. So after I converted all my grams to moles, these are the answers I got. Carbon 4.12, hydrogen 5.15, oxygen 1.03, and nitrogen is 2.06. And as you should remember, we are going to divide all 4 of these numbers by the smallest one, which in this case turns out to be 1.03. So you divide all of these by 1.03, and the answer you get would be 5 for hydrogen, obviously 1 for oxygen, and 2 for nitrogen. And what you have here are your prefixes for your chemical formula. Well, I take it back, your empirical formula. So what we have done now is we have found our empirical formula, and that would be C4H5O1 and N2. This is your empirical formula. Now you will add up all the masses of this empirical formula and you will find its empirical mass. So you will do C times 4, H times 5, O times 1, and N times 2. So go ahead and pause the video and find out its answer. So the empirical mass of this formula comes out to 97.097. Now your last step, well, the second last step, would be to find the answer for empirical mass. I apologize, I take it back. It is the molar mass, which is given in the problem, divided by the empirical mass, which we just found. So the molar mass was 190.19, which was given in the problem, divided by 97.097, and that will give you, so you have 2, and you will add, you'll multiply all your subscripts, and the answer you get is C8, H10, O2, and N4, and that happens to be the molecular formula of caffeine. So on the next slide, what I have done is I have given you the steps, and if you want, you're more than welcome to write these down and use these on the test, or you can just look at the example and solve your problem that way. Either ways, it's fine. In this next problem, you have to find percent composition. Now, you have to be careful, by the way this is worded. Even though it says find percent composition, your answer is not going to be in percentages. Instead, your answer will have the unit grams, because see what the question says. The question says find the amount. Okay, it does not say find percentages. It says find the amount in grams of carbon and oxygen in 50 grams of carbon dioxide. So there are a couple of ways to do this example. I'm going to go over one process, but if you want, you're more than welcome to do it other ways using simple proportions. So to start this problem, we've used the same approach that we have used in some of the other stoichiometry problems, which is that we will start off with what's given to us, which in this case is 50 grams of carbon dioxide. And you'll follow the same process that you have learned, which is to copy down the units on the bottom. So grams of CO2, which will turn into moles of CO2, and then you carry that down, so you get moles of CO2. Now at this point you have to think about what you're solving for. You're solving for carbon, and that would mean that moles of carbon dioxide will turn into moles of carbon, and then you carry down the moles of carbon and you convert that to grams of carbon, which is indeed the unit we're looking for, because we're trying to find the amount. Now that you have your units set up, it's time to put in the numbers for the units. So you put 1 for all the moles that are paired with grams, and 1 mole of carbon dioxide is 44.01 grams, and 1 mole of carbon is worth 12.011 grams. Now, as far as moles of carbon dioxide and moles of carbon are concerned, because carbon dioxide is bigger than carbon, you put 1 mole for carbon dioxide, and you'd be 1 mole of carbon for carbon dioxide. Now, where does that come from? It comes from the fact that when you look at carbon dioxide, this has 1 carbon and 2 oxygen atoms, right? So this 1 and 2, which is basically your subscripts, 1 and 2, those are the number of moles. And so now that you have all your numbers plugged in, it's time to do the math. So you will do 50 times 1 times 1 times 12.011 divided by 44.01 times 1 times 1. I know you didn't have to write all the ones, but it's just a habit, and that way I get to make sure that I'm not leaving any numbers that are not ones. So go ahead, pause the video and find the answer. And the answer I get is 13.65 grams. So what this means is that out of the 50 grams worth of carbon dioxide, 13.65 grams is because of carbon only. And the rest of the problem is now very simple. All you have to do to find the grams of oxygen is do this number and subtract it from 50, and that will give you the mass of oxygen. You will have 2 problems like this, so be sure to understand this process. Please make sure that you understand this chart, okay? Because if you have a chemical formula that has, let's say, 4 different elements, like the one of caffeine, right? If it has 4 different elements, then you will have to set up 4 of these charts, or at least 3 of these charts. So please make sure that you understand how this chart works. If you have any questions, please make sure that you ask those before the test starts. The next type of problems involve writing an equation by reading the statement and then balancing it. So here's the statement for you. Sodium hydroxide reacts with barium chloride to yield barium hydroxide and aqueous sodium chloride. So when you read this problem, you have 2 things you need to do. First is you will underline or highlight whatever to highlight your reactants. So your sodium hydroxide reacts with barium chloride, and then to yield, here's your solid barium hydroxide and aqueous sodium chloride. Now that you have identified your reactants and products, it is time to figure out the correct formulas. So let's do sodium hydroxide first. You know that sodium, and so this is the reactant side of the problem, which is NaOH plus BaCl2. And now you will have your arrow. That's your yield sign, basically. And what does it give you? It gives you barium hydroxide and aqueous sodium chloride. So let's figure out the formulas of your products. BaOH2 plus NaCl. Now that we have set up our reaction, there is one small detail that you must not forget. Notice that I have used the words solid and aqueous, and so you have to mention these in order to get full credit. And so to do that, you will use the alphabet S in parentheses and AQ in parentheses. Now your reaction is set up completely. All you have to do now is to balance it. So let's go over how to do that real quick. If you'll remember, we said that we will go element by element. So start off with your first element, which is sodium. It is already balanced on both sides. You move on to your second element, which is in this case a polyatomic ion. So you have 2 hydroxides over here, but you only have 1 hydroxide over here. So see what happens when you put a 2 in front of this sodium hydroxide. Now that you have 2 hydroxides on both sides, that kind of messed up your sodiums. So we'll go ahead and put a 2 in front of sodium chloride on your product side. And now you have 2 sodiums on each side. So moving on, you have 1 barium on each side. So that's already balanced. Then you have 2 chlorines and you have 2 chlorines. So your entire equation is balanced, and your subscripts, your coefficients are 2, 1, 1, and 2. Okay, so this is how you read a statement, write down the formulas, set up your equation, and then balance it. You will have 2 problems like this on your test on Tuesday. So sodium hydroxide being an ionic compound, you will have to balance out its charges. So sodium, you should know, is 1 positive, and hydroxide, which is a polyatomic ion, is 1 negative. And so the formula you get is NaOH. Your second reactant was barium chloride. So that is barium, which is 2 positive, and chloride is Cl, which is 1 negative. And so the formula you get would be BaCl2. And so these are your 2 reactants. So let's go back to our problem and write down your reactants. So barium would be Ba, still two positives, and hydroxide, as we know, is one negative. And to balance out your charges, you will need one more negative charge. And because hydroxide is a polyatomic ion, you will need parentheses around the hydroxide part, and so your formula becomes Ba parentheses OH2. Your second product was sodium chloride, which should be pretty simple because sodium is one positive and chloride is one negative, and so your formula becomes NaCl. And these are your two products, so let's go back and write these down. In this next problem, you have to learn how to write a statement. Forgive me for my comically large arrow, but that I couldn't figure out how to make it small. So anyways, we'll work with what we have. And so in this case, you have CaCl2 plus Na2CO3 yields CaCO3 and NaCl. One very important detail that I forgot to give you in this example, so I had to write it after the fact, was your parentheses phases in the bottom. So you have aqueous calcium chloride, aqueous sodium carbonate. You have solid calcium carbonate and aqueous sodium chloride. And so writing these statement is actually pretty simple as long as you know how to write names from a chemical formula. So let's start with your reactants. Your reactant is calcium chloride. How do I know this? Because you know Ca is calcium and Cl is chlorine, but because it is a non-metal, you will change its name to chloride. And so the first part of your answer would be calcium chloride, but because it is aqueous, you have to include that word, and so you will write. Matter of fact, before we write a statement, you have to balance it, and that's an important detail that I forgot to mention. So I apologize. I realize this video is kind of a mess, but we haven't done this for a while, so forgive my absent-mindedness. So let's go ahead and balance this equation. You will start with your first element, which is calcium. It's already balanced because you have one calcium on each side. So here's your one calcium and one calcium, so they're already balanced. You have two chlorines on the left and you have one on the right, and so what we'll do is we will add another NaCl. So you get two NaCl, and that balances your chlorines. Then you have two sodiums here and you have two sodiums here, because remember we added that too. And last but not least, you have one carbonate and one carbonate. So your equation is balanced. Just so that this is a little more clear, I'm going to rewrite the balanced equation. Okay, so now that I have cleanly written down this equation, we are ready to write down our statement. And so your first chemical would be CaCl2, which is called calcium chloride, but because it is aqueous, you will write aqueous calcium chloride, and there's only 1 mole of it, so you will write 1 mole of aqueous calcium chloride, then reacts with 1 mole of sodium carbonate to yield 1 mole of calcium carbonate, but because it is solid, it would be solid calcium carbonate, and 2 moles of aqueous sodium chloride. And so what I'm going to do is I'm going to pause the video and I'm going to write this statement down. So here's your statement. 1 mole of aqueous calcium chloride reacts with 1 mole of aqueous sodium carbonate to yield 1 mole of solid calcium carbonate and 2 moles of sodium chloride. This statement has all the information you need to write down this chemical equation. So these are the 4 types of problems you will have on your test. Again, I apologize for the poor quality of this video, but please make sure that you take good notes and come prepared for your test on Tuesday. As always, study well, and I'll see you at school.